My name is Brian Weber, and I'll be explaining Group 2's code. We were to design a sliding window for the data link layer. First thing I will do is a quick demonstration. The program asks you what protocol you'd like to demonstrate. We're going to choose go back in. This instance is the receiver, and then we're going to go run another instance in this window. Again, go back in, but this time it will be the sender, and then we can just type packets are represented as strings separated by spaces. You can see it'll send the packet. On the other end, it'll pick up the packet, send an acknowledgement for it, and then once the acknowledgement is received, it will move the window. We can send arbitrary strings in here, as well as arbitrary number of packets. Okay, let's take a look at the code. So there are 4 main files in here. The ones we're going to, the important ones are frame, framework, unidirectional, go back in, and app.java. We're not going to worry about go back in protocol. That was our attempt to create a bidirectional protocol, which proved very difficult. And we're not going to worry about the simplex, as that is, we were asked to focus on the go back in. Frame is pretty simple. All it is a place to store information, like what kind of frame it is, what number it is in a sequence, what acknowledgement it has, and what packet it contains. The only functions in this class are a constructor and getters and setters, and a toString, and this equals function that lets you compare frames. The framework is probably where we had to spend most of our time. Unfortunately, with this problem, it becomes very difficult just to implement just the data link layer, because all the data link layer does is communicate between the network layer and the physical layer. So the framework's job is to kind of create a mock-up of the physical layer and the network layer. And so what we did in our case is that we represent the physical layer by files on the disk. And so every time a packet gets sent out, it creates a new temporary file. And we represented the network layer as the command line. So command line is input is received, and then on the for the sender, and then the sender transfers it to physical layer, and then the receiver picks it up off the physical layer and puts it back onto the network layer, which would be like command line output. So we're going to go through this real quick. So in the initialize, the most important thing is it deletes all the existing temporary files in our temp file directory so that we start with like a clean slate. What we have to do here is we return the difference between 2 sets, and in this case the difference is just the larger minus the smaller, because we want to know what new files have been created. Generate checksum is no longer used. At one time the framework just did 1 file on the physical layer, but that proved to be not enough for the go back in protocol. The wait for event is fairly simple. Right now all it does is return either frame arrival or timeout. If there is a difference between what the list of known files we have and the files that are actually on disk, it means there's a new packet and we need to check what it is, and so it returns this frame arrival event. It is important to note though that whenever something is put on the physical layer, the framework adds that to the list of files that it knows, so that we don't get frame arrival events when we are sending frames. The other option is it looks through all the existing timers, and if any of them have, if our current time is greater than the timeout plus the time that the timer started, then we return a timeout. From network layer, all it does is scanner next, because we're just getting it from the command line. To network layer, just system.out.println. From physical layer is a little bit more complicated. So first we have to create a list of new files. The list of new files is maintained by wait for event. And so it's here, new files. Once we detect that there's been a change, it changes this class variable into what the new files were. So that from physical layer, all it has to do is it finds every single new file and sends it straight up to the data link layer. Now, unfortunately, our data link layer did have to handle buffering all these frames and then rearranging them, because there wasn't really a good way with this mock-up style to have the physical layer be wire-like and have it deliver frames in order. It's very difficult to have that and also have multiple outstanding frames, which was a requirement for go back in. Anyway, so it reads, yeah, I think that's all I want to say for that point is it reads every new file and delivers them up to the data link layer. To physical layer is a little bit simpler. All it does is creates a new temporary file with this clean built-in function that Java has, and we set that with our variable output file, which then we just write the object, our frame there, and then we just add it to our node files. So it's pretty simple. This is something that we didn't actually end up implementing, but we wanted to implement some way to fail some of the packets so that we could test, whether or not the protocol would recover. Unfortunately, we didn't have enough time to do that. Start timer just adds the current time to our array of running tires, and stop timer just removes it, or it's not an array, it's a map, excuse me. This way we can maintain multiple, it's just the start time of the timer, so whenever we want to find out, is the timer expired, we just say, is the time in the map plus the timeout less than our current time. Increment's pretty simple. It just increments whatever we put in and returns it up into max sequence number, and then if I is already equal to max sequence number, then we just reset it to 0. Pretty simple. Unidirectional go back in is what we were specifically asked to implement. Well, it wasn't specified whether the protocol needed to be unidirectional or not. We chose to do a unidirectional because that was much easier. So it's pretty simple. The send data function just adds the acknowledgement number and the packet to it, and then puts it on the physical layer and starts a timer. The sender, what it does is it has this while loop. If its next frame to send is less than the max sequence number, means there's still space in the window to send frames, and so we're going to send frames until we fill up that window. Then what we're going to do is we're going to wait for an event. The only possible cases are frame arrival and timeout. Frame arrival means that we've got an acknowledgement, and so then we'll pick up, again, like I said, the from physical layer is going to return whatever is new, changed, so we have to get all of them, we have to buffer them, and then we have to look through each one of them and check the acknowledgements. This is important. Getting in acknowledged implies that n-1, n-2, etc. are also received, so that's why this function here does not change the expected acknowledgement just once. It changes as many times as it needs to get n up into the most recent acknowledgement we've received. Because, for instance, if frame 5 has been acknowledged, then we know that frame 2, 3, and 4 have also been acknowledged because the receiver will not send acknowledgements except for in order. And so even if one of the acknowledgements gets lost in transit and we get like a more recent one, we can use that. Okay, what happens with the timeout is we just print out timeout, and then we reset the next frame to send to our expected acknowledgement back to where the last acknowledgement we didn't get. Okay. Next, we've got our receiver. The receiver just waits for an event, and then when it recognizes that something has changed on disk, it gets everything new off the disk and puts it into a buffer. And then what it does is it orders them, because we have to do okay, well, it doesn't quite order them. What it does is we look through everything in the buffer list and we find our next expected right here. We're looking for a next expected frame if it equals expected frame. And then what we do is if and when we find it, because there should be one in there that we find, then what we do is we send that that packet to the network layer, and then we send an acknowledgement for that one and tell the user that we're sending an acknowledgement. What we do after that is just remove that instance from our buffer frame list so that we won't be looking at it again, and we increment our expected frame. That's how the actual go back in is used. That's the most important part of the program. The only thing left is our app.java, which is just a simple command line input that it has a list of protocols that we support. It first asks the user, what protocol do you want to do, and then it sends to either demo simplex or demo go back in. We're just going to look at the go back in for now. Demo go back in, what that does is it initializes some initial parameters, which we could ask the user for, but in our case we didn't really need to, so we just hard-coded them. And then all it does is it just asks if it's a sender receiver, we call the sender, we call the receiver, and just runs until you close the program.